teacher Rosalie, and welcome to our statistics class. Are you familiar with the game See My Name? If yes, then let's have a short game. So what are the mystery words behind the pictures? We have the picture 1, the picture 2, and the picture 3. So we have 3 words. Okay, very good. That is the central limit theorem. We have the central limit theorem under the quarter 3, module 2. Let's consider the graphs. We have the graph 1, the graph 2, the graph 3, and the graph 4 with their corresponding sample size. So what do you observe to the 4 graphs with their sample size? Okay, very good. As the sample size increases, the more it approaches to normal distribution.
And that is the central limit theorem. It states that the sample mean distribution of a random variable will assume a near normal or normal distribution as the sample size increases. In simple terms, the theorem states that the sampling distribution of the mean approaches a normal distribution as the size of the sample increases, regardless of the shape of the original population distribution. We have the components of the central limit theorem. The mean of the sample equals the mean of the entire population. In calculating the mean of the samples of the population, just get the sum and find the average. The result will be the estimate of the population mean. We have also the standard deviation. The standard deviation of the sample is equal to the standard deviation of the population divided by the square root of the sample size. The central limit theorem is applicable for a sufficiently large sample sizes, or that is n is greater than or equal to 30. The formula for central limit theorem can be stated as follows. We have z equals the sample mean minus the population mean over the standard deviation divided by the square root of the sample size, where mu equals the population mean, x bar is the sample mean, the sigma is the standard deviation, and n is the sample size. Example number 1. A certain group of welfare recipients receives benefits of 110 pesos per week with a standard deviation of 20 pesos. If a random sample of 25 people is taken, what is the probability if their mean benefit will be greater than 120 pesos per week? So we have step 1, identify the given of the problem. So the mean or the average equals 110. The standard deviation is equal to 20. The sample mean is 120 and the sample size, that is 25. For the step 2, use the formula to find the z-score. So plug in the numbers from step 1. So we have the formula, and substituting the values, we have 120 minus 110 divided by 20 over the square root of 25. So we have 10 divided by 20 over 5. So we have now the final answer, that is z equals 2.5. Since we have now the values, that is 2.5, we can now proceed to step 3, and that is to draw a graph. And then, locate 2.5 on the graph. And that is now the application of the topic, the areas under the normal curve. For the step 4, look up the z-score in a table 1b. A z-score of 2.5 has an area of roughly 0.99379. However, this is not the final answer. The question is asking for greater than. and 0.99379 is the area on the left of C's score. So you need to subtract from 1. So 1 minus 0.99379 equals 0.00621 or 0.621%, and that is the probability of greater than 120 pesos per week. Now it's your turn. On page 30, what's more, solve the problems applying the central limit theorem. Show your complete solution. For number 1, the school record of weights of male students follow the normal distribution. The mean and the standard deviations are 70 kilograms and 50 kilograms respectively. If our researcher considers the records of 50 male students, then what would be the probability if the mean weight is less than 55? For number 2, biology exams have a skewed distribution with a mean of 75 and a standard deviation of 15. What's the chance that 100 students receive an average score higher than 80 on this exam? So you will answer that in 1 week.
That's all for today, and I hope you have learned something today. Again, this is Teacher Rosalyn saying, the more that you read, the more things you'll know. The more that you learn, the more places you'll go. Bye-bye! See you next lesson!